Hello friends, last 2 to 3 periods we already discussed about the stereochemistry. From this we already discussed about the conformation of alkenes, and we discussed some examples from the alkane, that is ethane, propane and N-butane. Now today we will discuss about the geometrical isomerism. Geometrical isomerism, here isomerism due to geometrical arrangements of groups about the doubly bonded carbon atoms is known as geometrical isomerism. Means this isomerism is related to doubly bonded carbon atom. Now there are two necessary conditions. One is that this compound must have the double bond or ring structure and second condition is that those substituents are attached to this double bond or ring, they must be unsymmetrical. Unsymmetrical means when any particular molecule which having the double bond or ring structure with unsymmetrical substituent shows the geometrical isomerism. Now there are two types of isomerism: cis and trans. Cis and trans isomerism. Cis and trans isomerism. Now we will see some examples related to this cis trans isomerism. Malic acid and fumaric acid. Now when you consider the structure related to double bond, here this is carbon-carbon double bond and the same groups are on the same side. Hydrogen on the same side and carboxylic acid are on the another side. Such type of isomerism are called as cis isomerism or cis isomer. At the same time, when this same group like carboxylic acid and this hydrogen are on the opposite side, then this is called as trans isomerism. Okay, means cis and trans isomerism is depending upon the same functional group or same atoms are present on the same side or opposite side. When same side groups are on the same side, then it is called as cis isomer, and when the same groups are on the opposite side, suppose here carboxylic acid and carboxylic acid are on the opposite side, then this is termed as trans isomers. Now we will see one more examples related to this. Here cis two butene and trans 2-butene. Trans 2-butene. Here also CH3 groups are on the same side, so this is cis, and here in this case CH3 are on the opposite side, so this is trans. Now we will move towards the EZ configuration. Now when we consider the cis-an trans-isomerism, suppose there are three different groups are attached to that doubly bonded carbon atom, then the cis-trans system is a failure. So there are more developed method for the nomenclature of this geometrical isomers, that is EZ configuration or EZ nomenclature. It is called as EZ nomenclature. Now this EZ nomenclature system is developed by Chan, Ingold and Prelog. So this system is called as CIP. This system is called as CIP, that is Chan, Ingold and Prelog. Actually Chan, Ingold and Prelog gives some sequence rule to decide the priority of the functional group. Sequence rule for priority of the substituents. Now here in this case suppose you consider here first priority group or higher priority groups are present on the same side and lower priority groups are on the another side, then this is called Z, and this Z word is coming from German word, that is ZUSAMEN, that is meant together. German, this word is coming from German word, this is German word, and the Z is nothing but these higher priority groups are on the same side, also the lower priority groups are on the another side. So this is Z. And suppose you consider the higher priority groups are on the opposite side, then as per the German word, this is E, and this E word is coming from ENTEGEN, ENTEGEN means opposite. Okay, these both words are coming from German. So E, okay, in case of E, higher priority groups are on the opposite side, but in case of Z, higher priority groups or lower priority groups are present on the same side. Now for the finding the priority of these substituents, the CIP rules are very important, and now we will discuss about the priority rules. There are various priority rules, and here first priority rule are suppose you consider here A group and B group are attached to same carbon atom, and there are some sequence rules for deciding whether A is prior or B is prior. So sequence rule first. sequence rule first. Actually sequence rule first is related to atomic number. It related to atomic number. Now here some elements we will use frequently. Now here atomic number, (53), (35), (17), (8), (7), (6) and 1. Now with the help of this sequence rule, we will take one example here. Now here we decide the priority in between Br and H. The atomic number of this Br is 35 and atomic number of hydrogen is 1. So in this case more prior group is bromine, so we will give the number here 1 and this is 2. In this case also 17 is the atomic number of chlorine and 1 is the atomic number of hydrogen. So these having first priority and these having second priority. So this is same groups are on the same priority, groups are on the same side, or higher priority groups are on the same side. So this is Z. This is Z. Okay. And in this case atomic number of chlorine is 17 and here 1. So chlorine having the first priority and hydrogen having second priority. Here chlorine atomic number is 17 and atomic number of bromine is 35. So this is bromine having the first priority and chlorine having the second priority. So it is E nomenclature and here Z nomenclature. Means for deciding the priority we will consider the atomic number of that particular elements. Okay. Now we will move toward the second sequence rule. Second sequence rule. Now here second sequence rule second. Here second sequence rule is related to next atom. For this we will take one example here. Now here we will decide the priority in between Br and H as well as in between CH3 and these CH2H groups. Now here no problem because Br having the first priority and hydrogen having the second priority. But when we consider the priority in between CH3 and these CH2H groups, here same groups are present. So in this case we consider the priority of next atom. So that's why this rule is called as next atom rule. Now here when we consider the next atom after this CH3, there are 3 hydrogens are present. So atomic number of this hydrogen is 1, atomic number of this hydrogen 1. So this is total 3. Sum of atomic numbers are 3. After this carbon atom there are oxygen and the atomic number of oxygen is 8. So that's why the priority of this CH2 group is higher, so this is 1 and this is 2. Now we will discuss again here. See, there are no problem because this Br is attached to carbon atom, this hydrogen is attached to carbon atom, so Br having the higher atomic number and hydrogen having the lower atomic number, so that's why Br having first priority and hydrogen having second priority. But in this case, here this carbon and this carbon having the same atomic number 6, and that's why this carbon not decide the which one is prior, so we will move toward the next atom. After this carbon atom there are 3 hydrogens, and you know very well about this hydrogen having 1 atomic number, so the sum of these atomic numbers are 3, and after this carbon atom there are oxygen, and the atomic number of oxygen is 8, so number is greater than this one, so CH2OH groups having the first priority and the CH3 having the second priority, and that's why this is E configuration. That's why this is E configuration. Now we will see one more example here. Now again there are no problem, this is 17 and 1, so this chlorine having the first priority and this hydrogen having the second priority. Now in this case this CH2 and this CH2 are the same group, so this CH2 can't decide the which one is prior, so we will move toward the next atom or next group. Again there are problem because this CH2 and this CH2 are same, then we will move toward the next atom. So this CH3 and this OH decide the which one is more prior. So in this case this CH3, this carbon atom having the 6 atomic number and this oxygen having the 8 atomic number, so this group having the first priority and this group having the second priority, and that's why this is the E configuration. This is the E configuration. Okay, now we will see next sequence rule, third sequence rule. Sequence rule number 3rd. Here this sequence rule is related to double or triple bond. Now for this, here this carbon double bond is considered that's like this. Suppose there are carbon oxygen double bond, then it consider okay. Suppose there are carbon triple bond, then this one is considered carbon and carbon. Now same carbon nitrogen triple bond, it consider nitrogen and nitrogen, and then we will sum all these 3 nitrogen, so the sum of these atomic numbers are here 21. Now suppose you take such type of example, then it consider N and N. Okay, so when there are different substituents are attached with double or triple bond, we consider by considering or it converted into such function group. Now we will take one example. We'll take one example here. Okay. Now here this having the first priority because this having the more atomic number, greater atomic number, and this hydrogen having the second priority. Now here this CO, as per the sequence rule number 3, this CO is considered as CO, O, and here H, and already you know here only CH3 group. So here 8 and 1. So total atomic number is 17, and in this case 6, and for these two hydrogens here 1, here 1, so this is only 8. So here 8 number and here 17 number, so 17 number is greater, that's why this having the first priority and this having the second priority, and on the basis of this is Z configuration. So these are the some sequence rule which is used for deciding whether it is E or Z nomenclature. Okay, thank you.